For years and years, I've been putting RJ45 plugs onto Ethernet cables like this, with closed plugs where you have to measure the length, or guess like this, and then hope and pray they all align up fully and properly at the tip and don't swap places inside without you realizing until it's too late, and then crimping with one of these standard tools. Although I got pretty good at it, I've still lost count over the years of the number of times I've had to snip an end off and start again from scratch, wasting a plug which can't be used again and making the cable shorter and shorter with each failure. Well, now there's a better way using a slightly different type of RJ45 plug and a different crimping tool. You will need a drum of Ethernet cable, probably either Cat5e, Cat6 or possibly even Cat6a. It will depend on your use case, but we won't get into the differences in this video. RJ45 plugs, make sure you buy pass-through plugs, sometimes called snap plugs, and optionally the strain relief boots, which help stop the little clip lever from snapping off. An RJ45 crimping tool, it must be one with a blade for snap plugs. A pair of snips and one of these mini wire stripper and punch down tools is useful to own and will also be useful if you want to wire up any wall sockets as well. And finally, a cable tester. This is essential to verify the cable and all 8 connections are correct and working before you go to use it in your network setup. I've left affiliate links in the video description for all these items. So take your wire cutters and cut however much cable you need for the cable run you're working on, being sure to leave a generous amount of excess, partly because a few centimetres will get chopped from either end, and because it's always better to have a little bit of excess rather than realise the cable's too short. Some crimping tools also include a cutter and a stripper, although I tend to use my own separate wire cutters and strippers, but it's up to you. If you're going to be putting strain relief boots on, slide one on now before you proceed to start putting the end on. Network cable consists of 4 twisted pairs, so 8 wires in total. Cat6 cable usually also has a loose plastic core running down the centre to reduce crosstalk between those 4 twisted pairs. Each pair is colour-coded, with one of the pair being a solid colour and the other is a tribute act to an American rock duo from Detroit. Strip off about a 3 cm length of the outer jacket, being careful not to damage the conductors inside. Snip off the plastic crosstalk separator and the ripcord thread that both run along inside the cable. Then untwist all 4 pairs of wires and pinch each wire tightly between your thumb and forefinger and run along like this to straighten them out as best you can. Next, it's time to arrange the 8 wires in the correct order so that we can feed them into the plug. I keep this little printout in my tub of connectors, or you can just Google RJ45 wiring diagram. There are 2 main standards, T568A and T568B. The only difference is the greens and the oranges trade places. The key importance is that the wiring is the same on both ends of the cable, so if you're just making a length of cable for yourself at home and terminating both ends with an RJ45 plug, then it really doesn't make any difference, as long as you use the same both end. I tend to use T568B because it's the most widely used. So that's orange and white, solid orange, green and white, solid blue, blue and white, solid green, brown and white, and solid brown. If you're adding cable to an existing setup or replacing a faulty end, then make sure you use whatever standard is already in use at the location to make things easier for yourself and any other engineers who might do work there after you. So arrange them in the right order and again, run your fingers along to help straighten them out even more so that they sit right and in the correct position. I find it helpful at this point to take my wire cutters and gently grip the cables, but don't snip them just yet, and to bunch the ends right up to each other and double check the colours are still in the correct order. Then, holding the base of the wires firmly with your thumb, snip a short length from the end so that we have a really neat, tight bunch at the end. Next, take an end plug. These pass-through ones, unlike the one I showed you at the start of the video, have open ends, which means you can poke the strands right through, allowing you to double-check the order is definitely correct before you commit and crimp the plug on, and it also guarantees that they all line up correctly and right to the very tip for a perfectly formed cable every time. So once you've cut a short length from the end, carefully slide the arranged wires into the plug and allow them to pass through it, hence the name, keeping going until the outer jacket, which is white in this case, is fully inside as far as it will go. Then examine the 8 wires and check again that all 8 are still in the correct order. If you accidentally loosened your grip too soon whilst putting the end on and any cables got in the wrong order, for example, you can of course just slide it off, correct and reinsert, without having to start again, waste a plug and make the cable a bit shorter again. Once you're happy with the end, insert into the crimping tool and squeeze it closed tightly. This will do two things. Not only will it crimp the plug, holding the entire cable in place and splicing all 8 contacts into the 8 wires, but the sharp blade on the rear will also trim all the excess off, resulting in a perfect, neat job every time. You can then slide the strain relief boot up and over the clip, and that's the first end done. Repeat exactly the same process with the same wiring order for the other end, and then be sure to test the cable with a cable tester like this. This checks all 8 wires individually. It will tell you that the 8 connections are good on both ends, and also that it's wired up correctly on both ends in the right order, or at least in the same order both ends. It does this by sending a pulse down each wire in turn from the master to the remote. You should see the sequence going from 1 to 8 on both ends, and when it does, you know the cable is working perfectly. If you get a sequence like this, then you know you've made a mistake somewhere. If it's a long cable run and both Cat5e and Cat6 cable are good for 100 meters, then you can separate the master and remote parts of the cable tester and put one at each end of the cable run to test it.